In today's lesson, we will be learning about our second type of transformation, which is called a reflection. We've already begun looking at reflections at the very beginning of the chapter when we reflected one point about the x and the y axis. After this lesson, you will be able to identify reflections and also reflect figures about in the coordinate plane. Let us first define what a reflection is. A reflection, or also called a flip might be a little bit more comfortable of a term for you to think about or visualize in your head until you get better at understanding what a reflection is. It is a transformation in which a figure is reflected in a line or over a line called the line of reflection. A reflection creates a mirror image of that original figure. So think of yourself when you look in a mirror and you were to either take a step back or take a step forward from that mirror, and how that changes the image that you see in the mirror, but how everything else about that image that you see, but maybe the distance away from the mirror, stays the same. So everything about you that you see in the image is congruent to yourself, but the distance away from that mirror changes when you take a step to or from, or maybe right or left in that mirror. The first thing that we're going to do is tell whether the figures are reflections of each other, and you need to explain why or why not. So if we're looking at number 1 here, we need to think about that definition, and we need to think about that mirror. So we're going to have that mirror right here. If we had this pentagon, which is a 5-sided figure, looking at the through the mirror, is this what they would see? Or is that a different type of transformation? And hopefully you're able to say, well, no, that is not what they would see in that image, through that mirror, because it's not a flip of the figure. Instead, you might be thinking, oh, well, that's just a translation of moving that pentagon down a little bit. So no, not a reflection. It is a translation. Why don't you guys pause the video and try 2 and 3. So in number 2, again, when we look at this, it's very similar to number 1 in that it just is taking one of the images and it's sliding it right over. I am not flipping it over to the other side. I couldn't fold the paper along that line and have them exactly match up. So again, number 2 is no. It's not a reflection. Again, it's a translation, sorry. Now number 3, hopefully you did notice on this one, here's my mirror, or my line that I would be folding my paper on. If I folded that paper, these 2 images would be exactly right on top of each other. They would be matching, and they would be a reflection of each other. This quadrilateral or 4-sided figure, trapezoid in this case, is looking in the mirror and can see that reflected or flipped image of itself over there. So yes, it is. And because it is a flipped, congruent image. So if maybe it was flipped but a different size, then it wouldn't be a reflection there. So it does have to be congruent figures. All right, the next thing that we're going to be doing is actually taking our different polygons that we're going to be making. So in this case, we're going to be making a quadrilateral, which again is just a 4-sided figure, and we're going to reflect it over the x-axis. Why don't you pause the video and graph these 4 points and make the quadrilateral QRST. Notice how I labeled each of my vertices, or the corners, each of the points, the dots on here, so that when I reflect the image, I will be able to tell which one is my, new Q value, which one is my new R value. And just like in translations, we are going to have that prime to mark what our image is from our pre-image. So I'm going to go ahead and write all of my letters here. And we are going to reflect over the x-axis first. So here is the x-axis. Remember that x-axis goes left and right. I'll even label that for us, and the y-axis is going up and down. So that is where we are going to imagine our mirror being, or where we would fold our line. So we are going to count our points from that line to get our mirror image on the other side of that line. So for example, our letter Q, if I start out there, it is one up from the x-axis, so I need to do go in the opposite direction and go one down from the x-axis, and that will be my Q prime. Our new coordinates of Q prime, is now -1, -1. So notice how our x value stays the same. It's still over to the left one, but now instead of up one, it goes down one. Let's do R together. And so R is up 3, 2, 3, and so now we're going to go down 3 from the x-axis. And that will get us our new R prime. Again, our x value stays 0 in this case, and it changed from up 3 to down 3. Go ahead and pause the video and see if you can do S and T on your own. So S is going up 2, 1, 2. Now we're going to go down 2. And that will be our new S prime. Now T might be a little tricky because T is not up or down from the x-axis. So if I were to fold that along the x-axis, or if I were to think something was right on my mirror, it's not going to go anywhere. It's going to stay right on my mirror in the reflection of it. So T prime does not move at all. And let's go back and let's give the coordinates of S prime and T prime. So T prime did not change, stayed at 4, 0, and our S prime became 3, -2. So I want you to look at all of these values, and we've talked about this already in class, but think about it again. Maybe you didn't quite see what was going on, but if you look at all of your x values, all of our x values stay the same when we are reflecting over the x-axis. But yet when you look at your y values, it was a +1, now it's a -1. It was a +3, now it's a -3. For the S, it was a +2, now it's a -2. And of course 0 is not going to change with that. When we are reflecting across the x-axis, we can summarize our movement, so we could do this without graphing, though I do recommend that we graph for a while until we get more comfortable. We just keep the x value the same, but then the y value becomes the opposite. So be careful with this negative sign. That doesn't mean necessarily negative, that means opposite. You might want to add this extra little tidbit of information, this word opposite right there. And note that the x stays the same. That way you can look back at your notes and understand what your mathematical terminology is meaning there. Let's try reflecting over the y-axis. So pause the video, make triangle XYZ, and then we will do a couple points together. Alright, so you should have your triangle XYZ. It should look like this. Now we are reflecting across the y-axis. So the y-axis is where we're going to imagine that mirror or fold our line. So we're going to count away from the y-axis. We're going to be thinking in terms of left and right now. the x is 1 away, or 1 to the right. Now it's going to become 1 to the left. Our x prime is now -1, +2. Let's do y. So y was 2 to the right again, and this time it's going to be 2 to the left. This will make our y prime be -2, +1 now. Hopefully you are seeing where your z will be. So our z, new z prime, is now again going to be to the left with this. And our new z prime is -1, -2. Hopefully when you're doing this, you notice, okay, well this time my x values are becoming opposite. They were all starting out to be positive, and our y values stay the same. So again, our rule for this is our x's become opposite. Again, it would be a good idea to write that word opposite. And our y values stay the same. Keep in mind the couple examples that we did so far, all of the points are on the x or on one of the sides. We'll do more examples in class where there's going to be some points on either side of the axis that we're reflecting on. So we got to take each point individually when we're doing the reflections. Don't forget to do your summary, 2 to 3 sentences. Pretend that you are trying to explain how to reflect across the x and the y-axis, and also to tell if two images are reflections of each other. You also have one question to do, so you're going to reflect this triangle ABC over the x-axis. Even if you're confident doing it without the graph, be sure that you do the graph of the pre-image, so the original ABC, and the image, the reflection on your graph.